Let's first look at convexity adjustment. Now suppose we have a contract that provides a payoff at time t, the maturity t. The payoff is structured as a function of yields. Okay, so you have a notional, have a annualized yield, and this is basically a time period. So if we're looking at the 3 months time period, then this annualized yield times this time period will give you the actual effective yield there that you can use to multiply to the notional. So here, this YT, say typically is the yield of a bond, let's say. So your payoff is related to yields. Now, how are you going to approach this kind of problem? Now, if you use the equivalent market yield measures approach, you can set up something like this. Say you use a zero coupon bond as a numerator. So the current price or the current value of the derivative asset is equal to this discount value times the expected value of the yield. Now those two are constant. So you can put them in front of the expectation. Now, if you have this expected value, you can just make a substitution. You'll get your price or the value of the derivative asset. Now, however, typically in the market, you don't have any observable variable that is equal to this expectation. Whereas, i.e., the expectation of the realized yield at maturity under the measure that is using this zero coupon bond as the numerator. Now, you don't have that. So what are you going to do? Typically, what you have in the market is that you do have an expected value of the price, the realized price at maturity. And that is basically, this thing is equal to the forward price of the bond. Now, so you do have a forward price observed for the bond. And out of this forward price, you can derive an implied yield here. However, that implied yield out of this forward price of the bond is not the expected yield, because the bond is a nonlinear function here. The bond price as a function of the yield is a nonlinear function. So, the yield implied from the forward price of the bond is not the expected yield. So what are you going to do? Now, although the yield implied from the forward price, so here F naught is the observed forward price at time equal to 0 of the bond, and from that, because you know the functional form, you can derive an implied yield here. But Y naught is not the implied yield. Sorry, Y naught's implied yield is not the expected yield. So you can't make a direct substitution and to calculate the price of this F naught here, right? But you can obtain this expected yield by making an adjustment based on this implied yield. And the adjustment would take this particular form, where sigma y that's used here is the volatility of the forward yield, and G prime and G double prime is the first and second partial derivatives of the forward bond price with respect to Y0. Now through this adjustment, you will obtain this expected yield. And once you obtain this expected yield with this particular expectation under this zero coupon bond as a numeraire, then you can make a direct substitution once you've done the adjustment back to here. Then you will get your initial price of the derivative asset.